All right, this is a video tutorial for the 1.6 section of the Big Ideas Geometry book titled Describing Angle Pairs. So hopefully by the end of this video tutorial you can identify complementary and supplementary angles and identify linear pairs and vertical angles. So two major core concepts are the words complementary and supplementary angles. Complementary angles are any two positive angles where their measures have a sum or a total of 90 degrees. The diagrams down below, the first two diagrams show complementary angles where they are added together and equal 90. They could be connecting to each other. They don't have to be connecting each other. The first one, they are next to each other. And that right angle box in the corner signifies that angles 1 and 2 add up to 90. And then the other one where it's separate, 20 and 70, those two add to 90. Supplementary is the same idea, but the two angles add up to equal 180. Again, they could be together. So that first diagram, angles 3 and 4 are a straight line angle. So angle 3 would be less than 90, and then angle 4 would be the supplement opposite to it, so that the total is 180. And then C and D is an example of what it may look like when they are not next to each other or touching. 115 plus 65 does give you 180. So complementary is 90, supplementary is 180. Okay, so here's an example. Given that angles 1 and 2 are complementary, figuring out, given that angle 1 is 62, what is the measure of angle 2? So one way you can approach this is to draw a diagram, and that's going to help you determine that you know that they are complementary, so they have to add up to equal to 90, and you could set up your diagram to show that they are connecting to each other. And you know that in order to get angle 2, you just have to take away 90 from the other one, because that's what the total is going to be. So 90 minus 62 will give you 28 degrees. Okay, so don't confuse the angle names with the angle measures. That little M in front of your angle symbol, that crooked L, says measure of angle 2. So that's what it's going to give you your degrees amount for the angle measure. Okay, part B is looking at angles 3 and 4 are supplementary. Given that angle 4 is 47, determine what the measure of angle 3 is. Again, it's nice to draw a picture. You know they're supplementary, so they could be a straight angle, where one of them is 47 and the other one measure of angle 3. To determine, you just have to take away 180 from the measure of angle 4, and 180 minus 47 will give you 133. Okay, in a figure, name a pair of complementary angles and a pair of supplementary angles and a pair of adjacent angles. Two angles are adjacent if they are next to each other or they are touching. So the way we can approach this is, you know that 37 and 53 will give you 90 degrees. So those two angle measures could be considered complementary. So BAC and RST are your complementary angles. Again, a reminder, your middle letter when you're describing your angle must be the vertex of the actual angle that is being measured. Okay, now moving on to a pair of supplementary angles. We have 127 and 53 that will give us 180. So looking at the angle pairs where the red and green lines pop up, labeling them as angle CAD and angle RST are supplementary, or they add up to 180. And then the last part, the pair of adjacent angles, the ones that share the same vertex and the same side, they are touching each other, they're right next to each other, are angles BAC and angles CAD, right there as the red and green. So notice how in this example, DAC and DAB, they do share a common vertex and a common side, and they do have same common interior points, but they are not adjacent angles. We're going to get into more specifically adjacent angles right here. So two adjacent angles that have non-common sides where they are opposite rays. So this very first diagram down at the bottom would be considered supplementary because it is on a straight line, and angles 1 and 2 will give you 180 degrees. And they have that same common side, which is the blue line, and the non-common sides, you could draw a straight line or create two different opposite rays between the vertex. So that's what a linear pair is. Vertical angles are two angles where the sides form two pairs of opposite rays. So really, in vertical angles, the most important thing is you have an intersection of two different lines that creates four angles, and the two angles that are opposite from each other are considered vertical. So 3 and 6 have the same vertex, but they don't have any of the common sides. 4 and 5 are your other pair of vertical angles. They share same vertex, but they don't share any common sides. Okay, so using the diagram right here, identify all linear pairs and all vertical angles in the figure. So to find the vertical angles, you're going to look for the ones that are formed by intersecting lines. So this red angle to describe number 1 and the green angle of number 5, they share a common vertex, but they don't have any common sides, and you can draw a straight line through to form the intersecting point. So 1 and 5 are vertical. To find the linear pairs, you're going to look for the adjacent angles, where the non-common sides are opposite rays or a straight line. So 1 and 4 is an example of a linear pair because the common side is being shared between 1 and 4, and then the non-common sides are opposite rays, or they are drawn a straight line between them. 4 and 5 are also a linear pair. 4 and 5 share a common side, and their non-common side has a straight line to form opposite rays. So in this example, one side of angle measure 1 and one side of angle measure 3 are opposite sides, but the angles themselves are not a linear pair because they don't share a common side. They are not adjacent. Notice that there's an angle 2 that is separating them. The diagram is sort of set up to confuse you that all of 1, 2, and 3 are supplementary for all three of them, but 1 and 3 are not a linear pair, nor are they vertical, because they have to have a common side between them along with the non-common side forming the opposite rays. So that diagram right here, highlighting the red and green lines, can help show that a little bit more, where that horizontal line forming the opposite rays does not match up with the common side, where angle 2 is created because it's a common side. All right, so two angles form a linear pair. The measure of one angle is 5 times the measure of the other angle, so you need to find the measure of each angle. One thing that's going to help you is to, again, continue drawing your diagrams. You know that it's going to be a linear pair, so draw a straight line and then a common side forming your vertex. And you know that one of your angles, you don't know what it is, but you do know the other one in relation to that is 5 times the other angle. So if you set your unknown variable to x on one of them, 5 times x will give you the measure of the other angle. And again, whenever you're multiplying a positive number times 5, it's increasing, so the 5x should be on your diagram at the larger angle side. Now, since you do know that they are a linear pair, they are also supplementary, so you can write an equation saying that these two angles added together will equal 180 degrees. So 1x plus 5x is 180. Then just simply using algebra to solve for x, combine like terms to get 6, and then undo your multiply 6 by doing the opposite, which is divide, and then you get x equals 30. Now the directions say to find the measure of each angle. This x equals 30 only tells you what the measure of one of your angles is, so you will need to plug it back into the other one 5 times 30 to get the measure of 150. One easy way to check is if you plug that back into your original equation, where this one is 150 and the other one is 30, double check and make sure that they add up to equal 180 and that they are supplementary.